Why are we in Norway?
Because Norway is one of the best countries in the world to see the northern lights.
Or the Aurora Borealis. Aurora was a Roman goddess of the dawn, and boreal is a Latin word meaning north, thus the northern lights. There's a lot of folklore about the northern lights, and various cultures from around the world have explained them as dancing spirits or blood raining from the clouds. The Vikings believed the northern lights were beams reflected from the shields of the Valkyries, female warriors serving their god Odin. The Aboriginals of Scandinavia, or the Sami, believed that the Northern Lights had supernatural powers to resolve conflicts. The Sami painted auroral symbols on their magic drums. In Middle Age Europe, the Northern Lights were thought to be reflections of heavenly warriors. As a reward, the soldiers that gave their lives for their king or country were allowed to battle on the skies forever. There are so many myths and legends and superstitions that have revolved around the Northern Lights throughout the history of mankind.
By the mid-1800s, scientists finally began to explain many of their mysteries. Like lightning or earthquakes, they are natural events, not supernatural ones. By the turn of the 20th century, scientists actually created artificial aurora in their laboratories. Christian Birkeland, a famous Norwegian scientist, created this device called the Torella, a magnetic sphere representing the Earth. Currently housed at the Norwegian Technical Museum, this device creates artificial aurora by using an electron gun similar to the one in your TV picture tube. Birkeland believed that currents of electrons from the sun caused the aurora. He laid the groundwork for the modern-day study of the northern lights. Today, thanks to modern research satellites, we now have a deeper and more complete understanding of how the northern lights work.
Isn't it true that the sun is the source of the auroras?
That's right, Jennifer. The sun does play a role in producing the aurora. The aurora are the only visible evidence that we have that the sun and the earth are a system that are connected by more than just gravity and sunlight. You see, the sun gives off charged particles called ions. These ions travel out into space at speeds of 350 to 700 kilometers per second. A cloud or gas of such ions and electrons is called a plasma. The stream of plasma coming from the sun is known as the solar wind. The sun's corona, or outermost atmosphere, continuously emits the solar wind, a stream of electrically charged particles, mostly protons and electrons, flowing out in all directions. It is commonly said that the aurora's gorgeous curtains of light are caused by particles flowing directly from the sun. But this is not the case at all. When a major solar storm interacts with the Earth's magnetic field, it causes some parts of this field to rearrange itself, like rubber bands pulled to their breaking point. The magnetic energy that is released causes powerful currents of particles to flow from distant parts of the magnetic field into the atmosphere. These currents flow along the magnetic field into the polar regions and collide with nitrogen and oxygen atoms in the atmosphere. The color of the aurora depends on which gas, oxygen or nitrogen, is being excited by the electrons. Oxygen emits either a greenish-yellow light, the most familiar color of the aurora, or a red light. Nitrogen generally gives off a blue light. The blending of these colors can also produce purples, pinks, and whites.
Stan, that is fascinating. And of course, it's beautiful.
That's right, it is beautiful. And you know, the northern lights are always moving, like giant curtains of light, weaving and swaying across the sky.
So Stan, how do scientists study the northern lights?
Well, besides photographing them from the ground, there are 3 other ways that scientists like to study them: ground-based measuring devices, sounding rockets, and satellites. Data can be collected from these 3 methods and analyzed by scientists to get a complete picture of the aurora borealis.